All right, the focus question for today is how do I rotate an image about a given point? Rotation. Let's start off with all rotations are counterclockwise. Unless stated otherwise. Counterclockwise, that's that direction, right? To the left, around to the left. When rotating, an image, around a center of rotation, all vertices must stay the same distance. From the center of rotation. Alright, so when you're rotating an image around a center of rotation, all the vertices of that shape must stay the same distance from the center of rotation. The angle formed by segments connecting corresponding vertices to the center of rotation is congruent to the angle of rotation. The angle formed by segments connecting corresponding vertices to the center of rotation is congruent to the angle of rotation. All right, so on your paper, go down some from your notes and go work towards kind of the middle of your paper, and we'll put a point on there. We'll call it K. We're going to do the example on the bottom of 640. We'll take triangle ABC. Make it a 90-degree triangle. That'll make it a little bit easier, I think. Okay, so you got triangle ABC, you got point K, and let's do 140 degrees. 140 degrees about K. So we're going to take this shape, ABC, this triangle ABC, we're going to rotate it 140 degrees about K. The instructions in the book are going to tell you to use a protractor and a ruler, but we're just going to get as close as you can without a protractor and a ruler, okay? So, if you can imagine a line going from point C through K and out the back, what would be the angle measure of that line?
180.
180. If you go from point C to K and then you go vertical, that would be 90, right? Okay, so if this much is 90 and this much is 180, wouldn't something like, if you split this second 90 in half, right about here, that would be another 45 degrees, wouldn't it? And 90 and 45 is 135. And for this assignment, 135 is close enough to 140. Okay? So you want to picture the angle that you're looking for here. So we're looking for about 140 degrees. So when you're going to connect your vertex, take your vertex now and you're going to connect it to the center of rotation. Hopefully your line's a little bit straighter than mine. That's pretty bad. So that would be 90. Vertical would be 90. And then we'll go right about there for 140. We'll call this 140. All right. So now somewhere along this 140 degree angle, we have to put point C prime. It needs to be the same distance from K. So let's make it, let's put it about right there. All right, and that's going to be C prime. All right, as long as this distance is the same as this distance. So there's our 140 degree angle, and our distance from the pre-image to the center of rotation to the image. Those two segments are congruent. Those two distances are congruent. Now what you want to do is you want to try to do the same thing with point A as close as you can. So if you go from A to your center of rotation, and then it's a little bit harder for you. If you continue this line right through K, that gives you a bearing on 180 degrees, doesn't it? And if you go perpendicular, this would be about 90. Okay? So do you see the distance between the blue and the red over here on the right side? You want to have the same distance between the blue and the red over here on this side. All right, so you're going to want to be about here. Okay? Now, the same distance from A to K, you want to have the same distance from A to K as you do from K to A prime. So you guys can, if you want to estimate it with the length of a couple fingers on your paper, or use a portion of your pencil, or a small portion of your calculator, or something like that, that's fine. It's just it's got to be as close as you can get it without measuring it. All right, so it's about that far is about, we'll say it's up about here. So we'll call that A prime. Okay? A to K is congruent to A prime to K. And you would do the same thing for B. So if you take point B and connect it to K, And if you were to put a straight line right through there, about 140, probably about through here. And if you go the same distance, you got B to K, point B to point K, congruent to K to B prime, be about there. Okay? Probably could have gone a little farther. There's a lot of lines. Sometimes it's a little bit confusing. But the point is, the key to this whole thing is that K to A and K to A prime are the same distance. K to C and K to C prime are the same distance. And K to B and K to B prime are the same distance. And that this purple or pink angle should be how many degrees? The 140 that we talked about, right? And the red angle should be 140. And the blue angle needs to be 140, or as close as you can get it. Okay? That gives you a 140 degree rotation about point K. Questions? All right, let's do one more rotation where the center of rotation is inside the image. So give yourself some room again. Put a point in the middle of your paper, call it K if you want. Again, it's going to be your center of rotation. And then we'll put triangle MNO around it. And this time we'll go 60 degrees. I'm gonna run out of room up top. 60 degrees about K. So 60 degrees about K. One thing, whether you're using a protractor or not using a protractor, just watch this for a second. If you've got a point of rotation, all right, anytime that you need to rotate around this point, it doesn't matter where your starting point is, okay? If your starting point's right here and you put a line right through your center of rotation, that's 180 degrees, isn't it? Okay? And if you can estimate a line perpendicular to that, okay, now you've got 90 degrees of rotation. And every time you keep breaking these in half, now you've got segments of 45 degrees, don't you? Okay, 45, 45, 45, 45, okay? Now, if you split all those in half, you're kind of creating a compass or a protractor right on your paper. When you're splitting all these 45 degree angles in half, you're making a bunch of angles that are 22.5 degrees, aren't you? Okay? So that can be helpful if you've got to rotate something. You know, maybe you don't have to rotate at 90 degrees. Maybe you got to rotate at 70 degrees. Okay? Well, you can get pretty close by taking, you know, what you know is a 90 degree angle and start breaking it down. If you're going to do a 60 degree rotation, take these two perpendicular lines, and if you need 60 degrees, well, if this is 90, if this angle right here is 90, you could split this into thirds, just kind of eyeballing it, you know? So now you've got 30, 60, 90 degrees, okay? And you want to get an idea in your head of how far you're rotating something before you start your rotation. So that would be pretty close to 60 degrees. This would be pretty close to 30 degrees. So back to this. We're going 60 degrees. We're taking each point, we're rotating it 60 degrees to the left. So start the process the same way. Take point O and connect it to K. And if you take a little 90-degree angle and draw it out of there, okay, you'll need 2/3 of that. So there's 1/3, so probably about right there would be your 60 degrees. So you want to keep the same distance away, so O prime would be about right there. Make sure that distance stays the same as that distance. If you take N and connect it to the center of rotation, you can estimate 90 would be about here, agreed? And then so 30, 60 would probably be about here. And N to K is congruent to K to N prime. Alright, you got a 60-degree angle right here. If you take another line and connect M to K, M to K, and then you can kind of estimate 90 would be about there. So 60 is about here. Same distance. Would be your M prime. And M prime to K, same distance as K to M. And you got a bunch of lines on there, but all right, something like that would be your 60-degree rotation about point K. Corresponding vertices are the same distance from the center of rotation, and the angle formed by corresponding vertices to the center is congruent to the angle of rotation. Any questions?